Okay, we're looking at the second quiz from the spring semester for Organic Chemistry 2. And this is kind of covering the end of Chapter 11, along with some of the review that we had from Organic Chemistry 1 there. So let's take a look at question 1 here. So we're given some alcohols and we're given sulfuric acid. We don't specify a temperature, so we assume it's lower temperature, right? And that's important because that makes us kind of recognize that low temp sulfuric acid, right, plus alcohol, that's going to push us towards formation of an ether. And remember, sulfuric acid with alcohol can do a couple of different things, but if we're looking at lower temperature, we're kind of going to be pushing towards this idea of formation of an ether. So let's quickly go through this mechanism here. I'm going to take a bit of a shortcut. Not a shortcut that's valid. Not a shortcut that's valid for you guys on a quiz or an exam, but for the sake of keeping the video short here. We're going to abbreviate sulfuric acid as H+. So we're going to send a lone pair in from our alcohol to grab that. So now we have a protonated alcohol. Let's see if we can follow here with our colors. Right? So we protonated our alcohol, and remember, this is the key point. Right? This is the key point of really Chapter 11 here, in that if we want to make alcohols into a leaving group, we have to do something to them. Right? We have to protonate them or react them with a Lewis acid to make some kind of positively charged alcohol, or the tosylates, which we talk about a little bit later. So now we have an alcohol here that's been protonated, so we have the makings for a good leaving group of water. We've got a secondary position here, so it's okay at forming a carbocation. It could potentially do a SN2 if we had a better nucleophile, but either case, right, we'll go through and generate a carbocation in this case, and we'll bring in our second equivalent. We'll bring in our second equivalent of alcohol. To bond there. Now we have the beginnings of our ether. Right, and so the last thing we need to do is have some kind of base come in and pluck off that hydrogen. Probably in this case it's going to be equal to another alcohol. So just for simplicity's sake there, we'll keep it simple. Okay, so that's our mechanism to get to our answer, and we got that there. Right, if we had higher temperature, we'd be doing an elimination likely, but in this case we're looking for an ether there. Okay, fantastic. Question number 2. We've got this cyclopentane ring here with a double bond and a methyl group and an alcohol, and we react that with thionyl bromide. Thionyl bromide plus all this stuff is going to be a nice way to swap our alcohol for a bromine. So we're just going to swap in a bromine there. Remember, when we're dealing with this thionyl bromide stuff, we sometimes have inversion of stereochemistry, we sometimes don't, right? It goes through a different mechanism. So in this case, we can assume that the stereochemistry stays the same, although if you guys came in and switched it and put a wedged bromine there, it wouldn't matter for us. We're not going to go into the nitty-gritty detail about how we know when the substitution for the alcohol to the bromine there comes in wedge or dash. If you guys were chemistry majors, then we'd go through and kind of drill down on that a little bit more. But for a non-majors course, this is just fine. Now, the second step here. So now we've got to stop and think here, right? So what do we have? Well, we've got a very good leaving group, right? We've got a very good leaving group. It's secondary. We're bringing in water, which is a poor nucleophile and a poor base. And so this is kind of a classic setup for an SN1 type reaction, where we're going to substitute that bromine. Okay? So this is a classic setup for an SN1 type reaction, which means we're going to go through a carbocation intermediate, which means we are going to shift things, and we're going to end up with an alcohol. So, and remember, as we go through the carbocation, we will make a racemic mixture of R and S there. So the second part here, I was asking you to remember, is how to do an SN1, right? How to do a substitution for a halide for an alcohol using a weak nucleophile, a weak base under SN1 type conditions. All right, question 3. Got that same kind of core structure there of a cyclopentane with our methyl group and our double bond. We got an alcohol, and we've got that COCl2, the oxalyl chloride with DMSO, and then triethylamine. This is our setup for a Swern oxidation. And a Swern oxidation takes an alcohol to either a ketone or an aldehyde, depending on whether it's a primary or secondary alcohol. So we have a secondary alcohol, so we're going to make a ketone here. So go through, right, all this other stuff unaffected. We got that. Great. Now we got the second part here. We've got a Grignard reagent, right? We've got a Grignard reagent here. That carbon in red there is bound to magnesium bromide, right? So really what you're seeing when you see a Grignard, right? Here's our red carbon. Really what we're seeing is that we have a carbon with a lone pair and a negative charge, right? The magnesium bromide, yes, it does something, but for the purposes of remembering what the reaction, right, we do really just have a carbon with a lone pair and a negative charge. And that's going to hit that ketone and pop that up. All right, so our product here, right, there's our oxygen. There's that purple bond that we made to our other carbons, and I'll just mark that one in red there. Right, and that magnesium bromide's hanging out with our negative charge there. Although, if you wanted to assume we did an aqueous acid workup, right, to go to the alcohol, that'd be just fine in this case too. Okay, so don't forget a Grignard with a ketone. We're going to hit that carbonyl carbon, pop up that pi bond, and form a new carbon-carbon bond there in purple, and leave behind some kind of oxygen species there. All right, so that's question number 1. It seems like a good place to pause before we work our way through the mechanism. So go through, make sure you review the stuff that's from the first semester of organic, and make sure you also, while you're working through the stuff that's from chapter 11.